Welcome to our next use case study here, our use case presentation. We've got Mike from Splunk. Everybody say hello.
Hello.
And then we've got Harish from Docker.
Hello.
And they're going to be here talking to us about some of the really cool stuff that's going on at Splunk with their use of Docker. I'm particularly interested. At Virginia Tech, we use Splunk quite a bit too, so I'm excited to see what's going on here too. And without further ado, I pass the time to them.
All right. Thank you. All right. Hello, everybody. It's the session after lunch, so please don't sleep. And I made sure I won't sleep. I just went and got what I thought was a double shot cappuccino. So I went there, told them, and they gave me this other coffee, and then they put 2 more shots in it. And then I realized that it was actually a 4-shot cappuccino because they prepared it for somebody else. So sorry if I keep walking too much here and there, but I think you'll get the context ready. Cool. So I'm Harish Jayakumar. I'm a solutions engineer at Docker. So as part of my role, what I do is I get the privilege of working with a lot of the customers on the field and work with them in, 1, adopting Docker inside their organization, or 2, if they're already using Docker, we help them move to the next stage, which is how do I use Docker now in production? How do I configure security? How do I do Active Directory and all those kinds of things which are much more complex than simply running a Hello World app in your laptop. So today with me, I have Mike Dickey, who's the Senior Director of Splunk. We've been working with Splunk for about almost 2 years now in adopting Docker inside their organization. So we've scaled from starting a very few nodes to several hundred nodes. So this talk, you're going to be learning about how Docker was adopted inside Splunk and how you're using it. This is the most important slide for today, so I'm going to pause till you guys read it and read it in entirety. But basically, it's the legal stuff. And after you read it, make sure also that at the end of the session, please vote for us. So what are we walking through today? We're going to start off basically with the Splunk's challenges. Like, what was the problem Splunk was trying to solve inside the company, right? And then we're going to talk about why they looked into Docker to see how to solve that problem. Then we're going to be talking about the commercial solution from Docker Inc., which is Docker Enterprise Edition. And that's the solution that Mike and his team is using inside Splunk. So we're going to be talking about how Splunk and Docker EE work together. And what's a DockerCon talk without a demo? So we will have a demo. And then we will talk about before Docker and after Docker metrics. And then finally, we'll end up with lessons learned, which is all the happiness and the pain we have gone through together for past 2 years. We'll want to share it with you. So when you go and start using Docker inside an organization, you could benefit out of that. With that, Mike.
Thanks, Harish. Splunk helps our 14,000 customers in over 110 countries analyze their machine data to deliver operational intelligence for security, IT, and their business. Splunk started out several years ago as a search tool for log files, but it's since expanded into many different use cases involving many different types of data. Splunk's products organization follows what we call the large-scale Scrum model, and as area owner for engineering infrastructure, it's my role to manage the backlog and priorities for 13 mission teams that are located in California and Shanghai. We're currently focused on test quality, automation, common tools, frameworks, and build systems, and we're working on a revamp of our overall test infrastructure, including CICD. When I started at Splunk a few years ago, we had several teams that were managing several different CI systems. They were running hundreds of different projects, hundreds of plans, and most of it was being manually managed by hand. Our lack of capacity meant that we had very large, long build queues, and our lack of great tooling meant that it could often take several days for us to set up and run large-scale performance tests. We had about 100 servers that we used for testing, and this is the state-of-the-art system that we used to manage them. It was literally a wiki page that engineers would go in and edit in order to reserve servers to run their different tests. Now, our customers are commonly using Splunk to process petabytes of data every day. We're continuously being asked to run larger and larger scale tests that require more and more hardware. We knew that this system would never scale, so we needed a better solution. Our engineers were very interested in containers. It was a fun and new technology, and Docker was already well established as the standard runtime engine and container image format. At the time, I was in charge of performance engineering, and what interested me the most was the promise for near bare metal performance and the consistency that you can get from running your tests within container images. We felt that Docker would be a very efficient way for us to automate the large-scale performance tests we have that span across hundreds of different servers. One of our teams ran a successful POC using Docker for CI, and we also ran many tests ourselves to prove to ourselves that we could use Docker for performance testing. We started out small with a few different pilot projects, and we gradually built support one person at a time. We built our momentum by expanding our use cases, and as our scope and our plans grew, so did our approval list, ultimately going up to our E-staff level for recent approval on our CICD expansion plans. When selecting a container orchestration system, we needed something that worked with both Linux and Windows. Many Splunk customers are Windows users, and we did not want to have to manage two different infrastructures to test on both platforms. We also needed something that integrated well with Active Directory and enabled us to control access to resources based on roles. Nowadays, most engineers already have Docker running on their laptops. It's increasingly becoming part of standard operating systems. So when an end user uses our Docker Enterprise Edition and the Docker APIs, they get a consistent experience regardless of whether they're running tests locally on their laptop or running them remotely within our data center. Perhaps most important is having good support from your vendor. And as you can see from the map, Docker is literally located right around the corner from Splunk. So it's a short 6-minute walk whenever I need to go and bang on Harish's door for help. You might also notice that there's a great brewery that's conveniently located in the middle. So if things really blow up on us, we can just go there and get hammered. But seriously, it's really important to have good support from a vendor who's able to prioritize the features that are important to your business. Later, Harish will demonstrate several of these features.
Cool. Thank you, Mike. So Mike just covered the reason they had picked Docker and why Docker Enterprise Edition. So what we're going to talk now is how Docker Enterprise Edition is being used inside Splunk. So we'll start off first by talking about just what is Docker Enterprise Edition, and then we'll walk through some of those features with the demo. So the Docker Enterprise Edition, or Docker EE for short, is basically made up of 3 components. First, there is a Docker Enterprise Engine, Docker Trusted Registry, and then the Docker Universal Control Plane. So the Docker Enterprise Engine, basically what it is from a functionality perspective, is the same as the open source engine, which is the Docker CE, which you get as soon as you just install it, Docker for Mac or Docker for Windows. But what you also get is support on top of it. We support releases up to a year. So for example, on the open source side, as we know, we have an engine that comes out every month, a month and a half. You're probably not going to be updating your engine in production every month. And we support almost up to a year. So even people who are still using 1.13 and all those releases, and we can be able to support it for them. Second, there are certified operating systems. So in production, there are a few operating systems that people want to make sure that the engine is certified and tested across it. That's the other thing we do with Docker EE that you don't do with CE. The third thing is bug fixes, right? So we talked about that 1-year support. So what happens if they're still using an engine from a year back and you find a security vulnerability or any known issues or any bugs in the current engine? We can actually backport those fixes back to the older version of the engine that they're using along with it. And of course, support. A production call goes down, a cluster goes down, you have a phone to pick up and call, and people will get on the phone and try to help you out. The second thing is Docker Trusted Registry. The Docker Trusted Registry is basically your on-prem version of the Docker Hub, but much more functionality added on top of it, right? So think of this as your registry where you store images, you have the same repos, organizations, all those things. But along with that, you have things like Active Directory and LDAP sync. You have multiple storage backends you can use. And then most importantly, signing and scanning. So with Docker Trusted Registry, you can sign your images, right? So you take an image, you can sign it. So for example, you can say that these are Splunk signed images, and only those images should be used inside my entire organization. This will actually prevent so that you just don't have any image you pull from the hub and use it across. So these are the enterprise capabilities you build on top of it. So it also becomes important when you're doing things like image provenance. So for example, a developer can sign the image, push it to DTR, and then DTR is Docker Trusted Registry, and then a tester can pull it, they can test it, and then they can sign on top of it, and then pre-prod can sign it, and then in production you can ensure that if dev, test, pre-prod, staging, all four have only signed, only then can you run the image in production. The other thing is scanning, which is it basically scans every time you do a Docker push. All the image layers are scanned to make sure there are known security vulnerabilities associated with it. And if it's there, it can prevent you from being promoted from one repo to another. Some of these are things that you guys must have seen in the keynote. Anyway, this is a high-level summary, but if you want more details, you can come by the booth and we can talk about it. The last piece is the universal control plane, which is the orchestration layer. Currently, it is based off the Docker Swarm, but as you guys saw in the announcement yesterday, Kubernetes will also be added along with this. So this is a single pane of glass for you to manage your entire cluster with things like what containers are healthy, deploying stacks, Active Directory, role-based authentication controls. The key important part on top of this is, again, this is completely infrastructure independent, right? You could run this on any of a Docker engine, which could be on an Amazon cloud, an Azure cloud, or Google cloud, or it could be another node which is in your private data center running on OpenStack or on bare metal. We don't care. And on top of that, again, it's a pluggable model, which is if you already have a CI/CD environment, you can plug into it. For example, Bamboo, Jenkins, any of those components. In the case of logging, you could use Splunk. And anything that you have will plug into directly with Docker Enterprise Edition. The key support, one more thing, what Mike was talking about is support for both Windows and Linux. That's a screenshot, as you'll see, of UCP, where you have both Windows and Linux nodes. I'll actually show that a little bit in the demo as well. The other thing we were talking about was a secure software supply chain. The same APIs, everything that you're using on your laptop. So if you do a Docker stack deploy on your laptop, the same commands, because it talks 100% Docker APIs, it could be used on the UCP cluster as well. And then hybrid applications, right? As you can see here, this is a compose file. Actually, I'll be deploying this in the cluster right now. But real quick, you can see how we've used constraints to say that throw this onto a Linux node and throw that onto a Windows node. And you can have them across the same overlay network that you're creating across this. So you can deploy hybrid applications also onto the UCP cluster. And this is one of the most important things as well, where I want to call out Mike's help. When we started off, we had a different style of role-based authentication control that was built into UCP, the first releases. But when we started working with organizations, and especially Mike was very pivotal in giving us inputs on how it is being used in scale and across large enterprises. So a completely new RBAC model was built in the latest release of UCP. Of course, I'm not going to go a deep dive on RBAC. Mark Church, another colleague of mine, actually did a talk yesterday. You should find it on YouTube pretty soon. But real high level, these are the four components, right? So it starts off with what is called as a collection, which talks about where the work can be done. So think of collection as like, what is I go and create? These networks, these nodes, these secrets. I create a collection out of all of this. So think of something creating like a production collection. And then the subject is who, what team, or who can go actually work on those collections. And the role is what is it that they can do on that collection. So that could be the role which you assign, which could be a scheduler role, or it could be read-only, read-write, all those roles that you want to assign over there. And all that translate to what is called as a grant. So a grant is a one-to-one mapping of a subject to a role to a collection. Who can do what, where. That's the whole mapping, and we'll walk through that in the demo as well. And extending that, what's available in the advanced version of Enterprise Edition, which is a key thing which, again, Splunk is using in their organization, is RBAC for nodes. So this is a good feedback we got from them when we built this, which is basically you can enforce node affinity and node anti-affinity. So you can actually say things like, these are the only nodes I want the application to be deployed on by this person, or these are the nodes I do not want this application to be deployed on. So that's another huge functionality that's built in. So when this becomes very, very important is when you have multiple teams. When you don't want to have spin up multiple clusters, you can use the same cluster and have this up and running. So this becomes very, very important when you have things like compliance and regulatory compliances, right? So at those points, this becomes very, very important as well. And coming soon, as you can see here, you have Today, the secure cluster management is Swarm-based, and then you can have Swarm and Kubernetes pretty soon in the next release. Currently, it's only Swarm, and then the nodes there, they can either be a kubelet or it could be a Swarm node. I'm glad I'm doing this on Wednesday so I could share this. All right, so let's look at the demo. We're going to be, if you see, this is the same slide that Mike had shown, the reasons for choosing Docker EE. So we'll walk through some of these things. The Windows RBAC. The only thing I want to I can't show here is the end-to-end support from the vendor or the beer drinking. But we could do that after this talk if you want to come join us.
Sacrifice.
Thanks. Oh, thank you. And with the tradition of DockerCon EU, you have to give a sacrifice. So here is my Lego. And if there are any Breaking Bad fans out there, that's Heisenberg. That's at least my version of Heisenberg I built. All right, cool. Good enough. So this is the universal control plane that we are talking about. So we're going to be logging into it. So as you all can see, basically I've logged in as an administrator to show you all the features that are there. So as soon as this loads, basically I have one manager node. You can obviously set it up in HA with having 3 or 5 manager nodes. And these are all my 4 worker nodes. So real upfront, as you can see here, these are the nodes that are there. So you see I have all these Linux nodes and Windows nodes that are part of the same cluster. And typically, even simply joining each of them and adding another node to the cluster is very, very simple, right? You pretty much is nothing but a swarm join. And then you can choose if you want it to be a Windows node or a Linux node, or if it wanted to be a manager or a worker. It's as simple as that, as joining a node to the cluster. Then what we're going to do is, let's go deploy a stack. So a stack, everybody knows, is something we introduced back in when it was the 112 engine. So we're going to go simply create a stack over here, before which let's walk through the compose file which you're going to be using. So as you can see here, it's one of these demos you must have seen, the same kind of compose file. I basically have an app server, and I have a database. And the key thing to kind of notice here, at least I'm tying the demo back to what Splunk is using, is the placement constraints, right? So I can actually say that node.platform.os is equal to Windows over here, and I can also say that the node platform over here is equal to Linux. So let's quickly and we're going to go create the stack. Let's call it final demo. So now you can choose services or containers, which is the Swarm Classic and the Swarm mode. We're just going to stick with services for now. And that's it. And let's create it. And just to show that I'm not lying, you can see here it's not preloaded. So now that this keeps coming up, you can see that the cluster is coming up, the application is getting deployed. So you can see here that there is the one network that was created, just one overlay network was created for both the containers. So both these services will be part of that same overlay network as you go. So it's done. Obviously, it's going to take some while to load. Let's see. See if the service is back. The database is loading. OK, let's give it some time. So while that loads, the other thing I want to talk about was the user management. So you can see here, these are the pieces that we are talking about: collections, grants, roles, and users, right? So you can see here that I have collections that is listed over here. So there's a shared and a system collection that comes usually with the cluster. And this is another collection that I created. Collections are basically hierarchical. So you can see here that there's a prod collection that I created, and I specified some nodes that should be only part of that prod collection, right? And that's the web server collection, which is part of the prod collection. Next, we can look at the users. So you see here, I have 4 users. There's an admin, Arya Stark, Cersei, and Jon Snow, part of the QA, ops, and dev teams. And we've assigned different roles to them in this. These are the roles you have. So you can actually assign, say, things like full control, scheduler, none, or you can actually go create your custom role from here too. So you can actually go create a role and say what operations you want them to be able to do. And then the grant. So the grant basically is what you've actually given in terms of this is the role on that specific service. So let's maybe log in as Cersei. So what I've done is Cersei is part of team operations, and I've given them scheduler access to one of the collections which I created called as the prod. So now when Cersei actually goes and deploys, it should only deploy it onto that collection. So let's log out here. Log in as Cersei. There. Now, just for the sake of time, I'm just going to create a simple service. And yeah, let's just use Redis. And create. So now this will actually go and deploy it only onto this. So the things is, everything that I'm showing on the UI can be done, by the way, through the CLI as well, because it's 100% Docker API compatible. So if you were to simply do the same Docker stack deploy from the CLI through Cersei's credentials, you'll have the same input over here. So now if you actually go inspect this, you can see here, there's actually deployed onto the production web server cluster. So that's it. Now let's quickly log out and make sure this is loaded. There you go. OK, just took some time. And that's the application. And as you can see, because this is an enterprise-grade demo, we have all the enterprise-level words like integrate, teamwork, synergy, etc. Thank you.
So we started out at Splunk by building a container-native test lab using 150 bare metal servers running UCP. Of course, we're Splunking all the data that we generate. So what you see here is the screenshot for an app that we built in Splunk to monitor and manage our own cluster. A few weeks ago, we launched Splunk 7, which includes native support for metrics. We were especially excited to dog food this new feature internally because we ran into a number of scalability challenges when trying to use the built-in metrics in UCP that leverage Prometheus. We currently have all of our servers sending data directly into Splunk using collectd, and we're able to run searches off both metrics and log data, all from the same interface. Splunk's the only thing that lets you do that today. We're using this now to monitor and manage our cluster, all aspects of it, and send out alerts whenever anything goes wrong. The chart in the lower left shows the number of containers that are running in each of our racks in our data center. And the green line that goes along the bottom represents the number of servers in each of those racks. The different colors represent the different types of workloads, with yellow for CI, red for regular test, and purple for our performance tests. Now, as you can see, we're typically bin packing between 20 and 30 containers per server for both our CI and our regular test workloads. But we're only running one container per server for all of our performance tests to ensure that they don't interfere with anything else. The chart on the right shows the different workloads over time. So as you can see, whenever a new job kicks off, there's a big spike in our CI containers. And the chart above that shows how we still are occasionally running out of capacity, despite the fact that we now have over 600 servers. So we plan to continue expanding this cluster over time. We use node labels to associate different racks with different workloads. So we schedule Affinity for the containers to match the node label where we want them to run. As I just mentioned, we want our performance test containers to be the only thing that's running on our servers. So to do that, we schedule the performance containers to have anti-affinity for a label that we set in all of our containers. And then we run all of our containers to have anti-affinity for a label that we set in our performance containers. And if you followed that, you deserve a cutesy whale sticker because it's kind of complicated. I'm amazed that I was actually able to get through saying it. We're hoping that the new features that were introduced in UCP 2.2 for role-based access control, as well as the CPU and memory reservation capabilities that are in the new swarm mode, will enable us to greatly simplify this approach. Internally, we built a tool that we call Orca, which we use to deploy test stacks for Splunk. The biggest feature about Orca is that it lets you use an any-style syntax to define test scenarios. And scenarios enable us to ensure that we have a very consistent environment from one test run to the next. One of our teams for a hackathon project built a Bitbucket plugin that leverages Orca to deploy test stacks directly from pull requests. So today, our engineers are able to easily deploy and test the code that they're reviewing, all with the click of a button directly from the pull request interface. We're also leveraging UCP as the foundation for our new CI/CD platform. We really like using Jenkins pipeline as code functionality, but we dislike using Jenkins agents. We found that agents are both difficult to manage, and they also create a big scalability bottleneck. Typically, you can only run about 200 agents per master. So what we did is we came up with an agentless architecture that leverages UCP to run every build stage as a container within UCP. And what we found is that that gives us a more consistent experience. It makes better use of our hardware, and it also scales much better. We found that we're able to run about 2,000 concurrent jobs with this architecture. At Splunk, we've managed to reduce the time that it takes us to set up large-scale performance tests from days down to minutes. We're making more efficient use of the hardware we have. We're running more tests more frequently, earlier in our release cycle, and that yields higher quality releases. The agentless architecture that we've come up with using Jenkins enables us to eliminate our CI/CD bottlenecks. And recently, Splunk 7 introduced a bunch of great new performance improvements, including about a 50% improvement in the performance of our data model acceleration feature. To test this and update our sizing guide, we ran hundreds of tests within the span of less than 2 weeks. And this kind of testing wasn't even possible for us to do before. Over time, we've expanded from about 150 servers in our data center to over 600 servers. And as you can see in the chart on the top, the blue bars represent the number of max servers in use at any point during a week. And the yellow line that goes through them represents the average number. So as you can see, as we've expanded capacity over time, we've also grown our utilization and grown into what we have. We started out with just a small team of developers using the infrastructure, and we've since grown it over the past year by over 4 times to over 100 unique users every week. Since the beginning of this year, over 385 Splunk employees have deployed over 1 million containers to test Splunk in this infrastructure. We're currently averaging between 10,000 and 20,000 test containers a day. In addition, we've also run over 30,000 CI jobs, and we're really just getting started with that. Now, 385 probably doesn't seem like a big number, but I can say it actually represents a very large percentage of our engineering organization. The biggest challenges that we've run into are really internal. The first one being with education. Containers are still a relatively new technology, so we had a lot to learn ourselves within engineering infrastructure, and we also had a lot to teach other teams. The second issue is something that everybody runs into whenever they're deploying physical infrastructure. Hardware, unfortunately, fails sometimes frequently, sometimes at very inconvenient times. So we've worked with IT many times to fix bad hard drives, bad memory chips, to fix load balancer configurations, networking issues. Everything that you can think of goes wrong. And it's really, these types of problems are often very difficult to troubleshoot. And when you combine it with the first issue of education, it's very natural for people to initially point fingers at whatever is the new thing in the room. And this requires a lot of patience, and it requires a lot of iteration to actually drill down and find the real problems. We started out using UCP 1.0. So as we expected, we ran into a lot of bugs since then. Some of the bugs that we ran into are related to placement strategies. So anti-affinity and affinity didn't quite work for us initially. We had some trouble with bin packing. LDEP had some issues with syncing all of the users in our organization. The role-based access control system that was initially rolled out with UCP before UCP 2 didn't really meet our needs. And we also ran into a number of performance and timeout issues at scale. The good news is that we've worked very closely with Docker's support team to troubleshoot and prioritize bug fixes, and most of these issues are fixed. So they've been great at that. And if you're starting out new today, you probably will have a much smoother road ahead for you. The first lesson that we learned probably seems obvious, but it's a really important one. It's to test things before you deploy them to production. We have a separate dev cluster where we always deploy new releases of UCP before we actually update our production cluster, and that's helped us to catch things early without impacting our users. The next is, as I mentioned, the root cause is not always obvious on the surface. So I like to follow a 5 whys approach, where you keep asking the question why and drilling one level deeper until you can actually pinpoint and identify the real problem. It's important to start small, iterate, over-communicate, and set good expectations, both for what you're doing as well as what you're not doing. It's important to monitor your cluster and set up alerts, using Splunk, of course, and to respond quickly to problems that you have. And of course, it's important to listen to your customers and deliver to them what they're asking you for. If you can, it's also important to invite contributions and participation from the community. With Orca at Splunk, anybody can create a pull request for any feature or thing they want to change. And I think this has helped a great deal in terms of both our engagement and our adoption. So thanks for coming today. If you have any questions, I think we have about 8 minutes left, 8 or 9 minutes.
Yep.
All right, so we do have some time for questions. If anybody has a question, please come to one of the mics so that it can be heard by everybody and part of the recording.
I'm curious what you did to smooth out that blame culture organizationally.
I think that the most important thing that we did is maintained our cool as much as possible, try to be patient, and try to use facts and really analyzing the issues and the problems and to demonstrate what's actually going wrong under the covers.
Just a question also, are you going to make available Splunk as images?
I believe we do have Splunk images on the Docker store today, but it's currently not officially supported. We're currently looking into that. I can't make any promises, but hopefully I know there's a lot of things that we're working on over the next year to build upon our partnership with Docker, and expect to see more to come.
I may have missed it, but for your concurrent 2,000 jobs, do you have spot instances, or do you just have a pool of like machines that are always up, or how is that set up?
Yeah, it's a great question. So we're currently using physical bare metal servers within a data center, but as we expand, we're evaluating different options and different vendors that might provide better cost advantages. So in the future, we might expand and start using spot instances. We also, with the way that we're architecting some of our testing, our regression testing, for example, takes over 8 hours to run through just the regression tests. So we have some intelligent schedulers that we've built where we run as many tests as we can, as frequently as we can, based on the available capacity, which essentially ensures that whatever capacity we have, we grow into.
I've got a question for Harish.
Sure.
So for the security aspect of signing images and stuff like that, have you ever had any issues with any organizations where they found it to be sort of one level too far, where it gets in the way of the process as such?
It's a great question. Everything depends on if it's done well in moderation, I think everybody kind of accepts it. What's advantageous with, and at least that's the philosophy with every product that's designed outside of Docker, right? It should be easy to use. Otherwise, you would never go out of your way to go do that. So our head of security, they felt that by default, when you simply do anything, it should be secure. So that's why when you simply spin up a Docker container, it's secure. So the signing piece was just the same way as well. all that weightage should be taken away from the developer, right? As if you simply just enable export Docker content trust equals 1, you can sign the image. Everything else, all that other heavy weightage, is pretty much handled either on the CI/CD pipeline. So for example, the case we were talking about, say, from a user going to test to dev, that's pretty much not what something anybody else would be doing manually, right? I'm assuming you do that using like a CI/CD workflow, where Jenkins would do the signing and all those components associated with it. So no, I haven't seen anybody, I know I went far, but no, I haven't seen anybody complain. And if at all they have an issue, it's more of just, again, back to educating it and trying to work around it.
How does it sort of fit in with DevOps? Because as my job, I'm sort of a bit of both, if you know what I mean?
Yeah.
We don't really have an ops team that deploys our stuff. It's the team, we build it, we run it, you ship it. If you want somebody who's not a developer to sign an image, how does that fit in?
Yeah, so I mean, pretty much DevOps is kind of very critical and key to this entire process as well, right? So even if you don't have an ops team, you're pretty much wearing that hat as the ops person as well, enabling those components. So yeah, you can always enable them at the engine level. Right now, signing is on the client side, right? So you would do the signing there, but the scanning piece is something you would enable per repo on the DTR side.
Thank you.
Sure.
Any other questions?
All right, so I think Mike and I can go have the beer then.
All right, so let's go ahead and give these guys one more round of applause.